Hello everyone, this is Vardman and welcome back. This video is continuation of analysis of algorithm. So this is the part 3 and this will be the final video. We have couple more questions to complete before we move to our next topic. Let's check our next question. We have our main function here, and inside the main function we have two statements. First is I equal to 2 and second is inside the while loop I equal to I square. So here the first statement is consuming 1 unit of time as it is a single statement, and for the second statement it is also consuming 1 unit of time, but the second statement is inside a while loop. So let's check how while loop is working. So the initial condition of while loop is I equal to 2 and the termination condition is I should be smaller than or equal to n. If the value of I will be greater than n, then the loop will terminate. Here the increment condition is I equal to I square. So every time it is making the square of I. Now let's see. We have the initial value of I equal to 2. So when it will go inside the loop first time, so in the first iteration the value of I will become 2 square. In the second iteration it will again get squared, so 2 square will get squared, which can be written as 2 raised to the power 4. And after the third iteration, so it will get again squared, so 2 raised to the power 4 will get squared, and this can be written as 2 raised to the power 8. Now here we have initial value as 2, so 2 can be written as 2 raised to the power 1, and this can be written as 2 and 2 raised to the power 0. For 2 square we can write it as 2 itself, and 2 can be written as 2 raised to the power 1. Next we have 2 raised to the power 4. This can be written as 2 here, and 4 can be written as 2 raised to the power 2. So in the next we have 2 raised to the power 8, which can be written as 2, and 8 can be written as 2 raised to the power 3. So for first iteration we have 1, for second iteration we have 2 here, and for third iteration we have 3 here. So the loop will run a total of k times, and after the k times the loop will terminate because the value of I will become greater than n. So at the k iteration we can write the value of I will become 2 raised to the power k. So this is the value at k times, which will be equal to n. So this is the last time our loop will run, and after this time then it will become 2 raised to the power k plus 1. In the next iteration the loop will terminate because this will be greater than n. Now let's solve this equation for the value of k. So here we have 2 raised to the power k equal to n. So now we will take log both side. So log 2 raised to the power k, and here it will become log n. So here base will be 2. This can be written as 2 raised to the power k log 2 raised to the power 2, which is equal to log n. This will be equal to 1. So we have 2 raised to the power k equal to log base 2 n. Here we have to take the log both side again. So this will be written as log 2 raised to the power k equal to log of log n, which is base 2. Now k can be written in front, and this will become log 2 base 2, which is equal to log base 2 log base 2 n. So this will written as k equal to log base 2 log base 2 n. So the overall complexity of this will be 1, which is for the first statement, and for the second statement which is running k times, so which is log n. This will be our final time complexity. big O of 1 plus log n, which can be written as big O of log n. Now let's see the ninth question. So this is a kind of similar question, so we will not deep dive into the loop. So let's do a basic understanding of the loop. So initial value of I is 0, so we can write at the first iteration the value of I will be n, and inside the while loop the termination condition is I should be greater than 2. When the termination condition is false, then the loop will terminate, so I should be greater than 2 always. And the increment condition is I equal to I की power 1 by 2, which is also written as I equal to under root I, so 1 by 2 is root. Now let's see for first iteration the value of n and I will become, so the value of I will become n to the power 1 by 2, and after second iteration it will go again inside the loop and it will get again rooted, so it will become n 1 by 2 की power 2. After third iteration the value of I will become n power 1 by 2 to the power 3. So this pattern will keep on running k times, and after k times the value of I will become n to the power 1 by 2k. So here the loop will run a k times, and after k times this will become equal to 2, and in the k plus 1 iteration the loop will terminate because it will become smaller than 2. So now n 1 by 2 की power k becomes equal to 2 after the k iteration. So this will be solved and k will be the final answer. So let's solve for the value of k. So we have n 1 by 2 की power k equal to 2. Now let's take log both side, log n 1 by 2 power k, and here it will come log base 2 2, so base will be 2, so this 1 by 2k can come in front and this will be log base 2 n, and this will become 1. Now we can write this as log base 2n, 2 raised to the power k can come this side, and now here we will take the log again. So log base 2n equal to k log 2. This will again become 1, so k will become k equal to log base 2 log n. So this is the final answer, and the time complexity will be big O of log n. Let's see another question. Here I have already solved the question because I want to show you how you can take log efficiently. So here inside the while loop we have three statements: I equal to I plus 2, I equal to I into 2, I equal to I cube. If we compare the first two statements with the third statement, so here the first two statements will generate a lot smaller value as compared to I cube for a large number. So we will consider only I cube as an increment statement. Now let's see how we can solve the question. So here the initial value of I is 10. In the first station this value will be cubed, so we can write as 10 raised to the power 3 raised to the power 1. For second station we can write as 10 raised to the power 3 raised to the power 2. For third station it will become 10 3 raised to the power 2, and it will run a total of k times, and after kth iteration the value will become 10 3 raised to the power k, because after this iteration the loop will terminate and this will be equal to n. So at the k plus 1 iteration the loop will terminate. Now let's solve this equation and find the value of k, so that will be our answer. So first we will take log both side. So this time we will take log base 10 because we have to remove the 10 first. So here side will become log base 10 raised to the power 3 raised to the power k, and here it will be log base 10 n. So 3 raised to the power k will come in front, and log base 10 can be written as 1. Now the answer will become 3 raised to the power k equal to log base 10 n. Now we can take the log again. So the k will come in front, and it can be written as log base 3, and log base 3 can be written as 1. So the final answer will be k log base 3 and log base 10 n. So here what will be the base can be written as 10 and the power can be written as 3. So the final answer will be big O of log n. Let's see up the next question. So we have our main statement here, and inside the main function we have two loops. So this is a nested loop. Let's see the outside loop. So the outside loop is running from I equal to 1, and it will run until the value of I is smaller than or equal to n, and this is incremented 1 every time, so it is I plus plus. Now let's see the inside loop, the nested one. So it is running from j equal to 1, and the value of j is dependent on I, so it will run until the value of j is smaller than I. So this is dependent of I, and it is incrementing by 1 every time, j plus plus. And inside it we have only one statement, so this statement will take 1 unit of time. Now let's see how many time this statement is going to run, because it's inside a nested loop. Let's keep a track of value of I here. So when the value of I is 1, then value of j will be 1. So here it is terminating in the first condition itself, because j equal to 1 and it is equal to 1, so the I or j value will be same, so loop will terminate here. Then the second round, the value of I will become 2, and for 2 the inner loop will run 2 times, for the value of 1 and for the value of 2. Similarly, when the value of I will be incremented to 3, then it will run from j equal to 1, it will run for 2 and for 3 also, and when the value is 3 it become equal to I and the loop will terminate. So we will again increment the value of I, so this will go on until the value of I becomes n, because here the condition is I should be smaller than equal to n, so this will be last time when the I loop will run. And for the I loop, the j loop will run from 1 to 3, and this will also run till n times. After the value of j become n, so it will become equal to I and it will terminate. So let's see how many times the j statement, j loop is running. So here we can see this is running 1 time, now is running 2 times, for the value of 3 it is running 3 times, and for the value of n it is running a total of n times. Now if we sum up these all values, 1 plus 2 plus 3 up to n, so we have a formula here. So this is the sum of natural number from 1 to n. So the formula is n into n plus 1 by 2. So this is our formula for sum of natural numbers, and here we can see the pattern is sum of natural number. So here our value will become n plus 1 by 2, which is equal to n square plus n by 2. So this is our time complexity, and we can write it as big O of n square, because other things can be ignored. Let's look at the last question for the video. So here we have a nested for loop, and this for loop is running from I equal to 1, and it will run until the value of I is smaller than log n, and it is incrementing by 1 each time. And the inside loop, which is a nested one, it will run from j equal to 1, and it will run until the value of j is smaller than equal to 2 raised to the power I. So this one is also dependent on the power, the value of I, and this is incrementing j plus 1 every time. And here we have a single statement inside it, so it will consume 1 unit of time. but it's inside the nested for loop. So let's calculate how many times it will run. So here, if we track the value of I, when the value of I is 1, so the inside loop will run from j equal to 1 to 2 raised to the power 1. So we can say the j loop will run 2 raised to the power 1 time. Now the value of I will be incremented to 2. So this time around the value of j will be starting from 1 to 2 raised to the power 2. So it will run a total of 2 raised to the power 2 times. Similarly for 3, it will run total of 2 raised to the power 3 times. And for the value of n, at some point this loop will run up to log n times. So when the value of I is log n, you can see this loop is running from log n, not n. So the value that time of j, like how many times j will run, it will be 2 raised to the power log n. Now if we sum up these value, 2 raised to the power 1, 2 raised to the power 2, raised to the power 3, so this is how many times our inner loop will run. So let's calculate. So 2 raised to the power 1 plus 2 raised to the power 2 plus 2 raised to the power 3 up to 2 raised to the power log n. So here we can identify this as a GP series. So for GP series we have a formula. To sum up the value of GP, we have formula A multiplied by R into n minus 1 R minus 1. Here R is 2 and A is also 2 and n is log n. So we can substitute the value. A is the first value, which is 2. R is the difference between them. So it is 2, and how many times it is? So we have log n here minus 1, and R minus 1 is 2 minus 1. So we can write this as denominator will be 1, and here we can write it as 2 raised to the power log n plus 1 minus 2. So this 2 minus 2 can be ignored, and we have the final value 2 raised to the power log base 2. So this plus 1 and minus 2 both can be ignored because they are very small if we compare for a large number. So this will be the final value. And here in log we have a formula. So if we have A raised to the power log n base A and B. So this can be written as, if these two values are same, then it can be written as B log base A. So this will be replaced, the position of A and B can be replaced. So here similarly we can do with our value here. So this can be written as n will come down and 2 will go up, log base 2 2, and this value is equal to, when the base and the log is same, then we can say it as 1. So the final value we have will be n. So this example is taking a total of big O of n. So this is our final time complexity.